Hello and welcome to our dilution notes video. Here we are going to take a look at what happens when we change the molarity of a solution. We'll look at how we calculate that change and what does it mean about the solution. So as you're taking your notes, please write down all the information, any diagrams, and examples done. All right, so just to review what we've looked at so far, molarity is the number of moles of solute per liter of solution. So if we made a solution as shown in this picture, it is a 2 molar NaCl solution. So let's just say that this is 1 liter of that solution. So that means that we have 2 moles for every 1 liter of solution. Okay, so we would have 2 moles of NaCl dissolved in this beaker here. So if we wanted to change that, if we had 2 liters, then we would have 4 moles of solute. So if I had another beaker that was 1 liter and it was a 2 molar solution, I would have a total of 2 liters. And I would have 2 molar solution. So I would have 2 moles in each, so I'd have a total of 4 moles of solute in that, of sodium chloride dissolved in that. So it is a ratio of moles per liter. So molarity, as we've seen, is our number of moles per liter, is a ratio. We've talked a lot about ratios this year, especially in the last unit. So what do we do when we change that ratio? So let's look at what would happen if we change that solution. What if we added water to our solution? So adding more water to the solution is what we call a dilution. So something that is more dilute has more volume to it, typically more water added. So dilution is the process of decreasing the concentration of a solute in a solution, usually by mixing with more solvent, like adding more water to the solution. The amount of solvent, the thing we're dissolving, or our moles, does not change, and that's really key to this. So for example, again, our 2 molar sodium chloride solution, if I took that and doubled the volume, so now I have 2 liters, so I just take that and add more water to it, so now it's 2 liters. We have the same number of sodium chloride particles in there, right? All those our little atoms. So if we did that, we have 2 moles now in 2 liters of solution. So we took the same 2 molar solution. We started out with 2 moles per liter, and now we've increased our amount of water. Now we have 2 moles in 2 liters of solution. So that's going to cut our volume in half. So doubling the volume cuts the molarity in half. Sorry about that. So if we take our solution, our original solution, we don't add any more chemical, we only add water, we're only changing the volume of it, not the actual moles of solute. So it's going to dilute it and make it a lower concentration. So how can we calculate the new molarity of any solution? So we have this equation, it's called our dilution equation, M1V1 equals M2V2. So the 1s and the 2s in this equation just help us pair up the molarity of a solution with its volume. So the M represents molarity, and the V represents volume. Okay, our molarities units, again, are those capital M. Volumes units can be liters, or we can see it in milliliters. The key to this is when we're using this equation, as long as your units for volume are the same, you can use either one, okay? They just have to be consistent. So a question might look like this example. A 50 milliliter sample of 2.5 molar HCl is diluted to a final volume of 200 milliliters. What is the molarity of the resulting solution? So let's just sketch this and see what's going on. We've got a container. We've got 50 milliliters of solution in it. So that's our volume marking on there. And it has a 2.5 molar concentration. All right, so 2.5 moles per liter. Now, we are going to add more, so let's pretend this container is bigger. We're going to add more liquid to it until it reaches a new volume of 200 milliliters. So we want to know, as we spread out this HCl, right? We've got the same amount of HCl, we're only adding water. What's our new molarity going to be? Okay, so when we increase the volume, it should decrease the molarity. So let's check it out. We're going to use our equation M1V1 equals M2V2. So when you read the question, it's important to pair up your information. If we look, it says a 50 milliliter sample of 2.5 molar. Those two are paired together. So I'm going to connect them like that. And then we've got our 200 milliliters. That's our final volume. It says what is the molarity of the resulting solution of that final one. So we've got our 200 milliliters. And we're looking for its molarity. So that's going to go with our variable, our missing one. All right, so we're going to plug this in. Now, it doesn't matter which ones go on the 1 side and which ones go on the 2 side. It's the same. You'll end up with the same answer. So I'm just going to start on the left. M1V1, I've got a molarity, 2.5 molar, times a volume, 50 milliliters. That's going to be equal to molarity number 2, which we don't have, that new molarity, times its volume, 200 milliliters. Notice that both of the volumes are in milliliters. Those units are consistent, so we are fine with those. So now that we have this set up, we're basically solving for M2. You can think of it like solving for X. In math, in your algebra classes, you've done the same thing. So we want to isolate that variable. So the next thing we're going to do is divide by our 200 milliliters on both sides. Oops, 200 milliliters. Fix that. And then we can calculate. So M2 equals 2.5 times 50 divided by 200. And our final answer is 0.625. Now, units, we are canceling our milliliters and we are left with our capital M, which is our molarity. So our new concentration, when we take this solution and we add more water to it, it's going to spread that out and dilute the solution. So we have a new solution with a molarity of 0.625. We can see it started at 2.5 and it's diluted to 6.25. So it decreased the molarity when we increase the volume. Let's try some more examples. All right, the next one, a student needs to make 250 milliliters of a 5 molar NaOH solution. So those two are paired together. It says they have 16 molar stock solution available. What volume of stock solution? So those two are paired together. You don't have to draw the lines like I am. You can maybe color code, highlight, label, however you want to do it. So another way we could show that without the lines, we could say these are 1 and 1, and this is 2 and 2. Pair them up like that. So what volume of stock solution do they need to make their solution? So when we say stock solution, okay, that's typically a concentrated solution. So it's the one with higher molarity, has a higher molarity than our dilute solution. Stock solutions, a lot of times they call them that also because they're stored in the stock room. So it's like the back room in my classroom. Okay. So we have them paired up, so we're going to plug them into our equation. Remember, it's M1V1 equals M2V2. So I've got my ones. Also, you've got your volume and molarity. If I wanted to, I could always write my volume first and then my molarity. That's fine. Either order, they're still being multiplied by each other, so everything works out. Equals M2V2. So we know our molarity of our stock solution. We need to know how much of it we are measuring. What volume of it do we need? Okay, so just like our previous question, we're going to first isolate that volume. So we want to divide by our 16 molar solution and get our volume 2. So we've got 250 times 5 divided by 16. And that gives us 78.125. I'm going to go ahead and say 17.1 is fine. Now your units, your molarities cancel, so that's milliliters. So let's look at what this is saying. This is saying I want to make 250 milliliters of 5 molar NaOH. So what I would do is into my container, I would add 78.1 milliliters of 16 molar stock solution, and then I would fill it up with water till it reaches a final volume of 250 milliliters. When we fill it up with water and get to that, now we have that 5 molar NaOH solution. Okay, so we're kind of looking at it backwards. We're saying, okay, if we needed to make a specific concentration solution, what do we start with? How much do we measure? And that's what I do all the time when I make chemicals for your labs. I figure out how much do I need to measure of my stock solution to make a specific molarity and a specific volume of it, and then I measure it and fill it with water. All right, let's try one more question. So 100 milliliters of water is added to a 5 molar calcium hydroxide solution with a volume of 45 milliliters. What is the molarity of the diluted solution? So if we look at this, again, we want to be careful with reading the question. So I've got 1 molarity and 2 volumes here. I need to figure out which volume goes with this molarity. So it says 100 milliliters of water is added to a 0.5 molar solution. Well, at that 0.5 molar, that's not how much I don't have 100 milliliters, I'm adding 100 milliliters. It says with a volume of 45. So this one goes with this one. Okay, the 0.5 has a volume of 45 milliliters. We are adding 100 milliliters to that. Okay, so let's think about that. If I have 45 milliliters in my container, maybe it's right there, and I add to it 100 milliliters, okay, it doesn't say my final volume is 100, it says I'm adding 100 milliliters of water. So our final volume, our total volume, is 100 plus 45, which gives us 145 milliliters. That is our new volume. And we want to know what our new molarity is when we do that. So let's plug into our equation. So I know I've got M1, and that's paired with V1, 45 milliliters. And I don't know my new molarity, but I know I have a total of 145 milliliters when we add in that 100 milliliters of water. So now we have to solve. Again, we want to isolate M2, so we're going to divide by 145 milliliters on both sides. We can see our milliliters will cancel. And we can calculate 0.5 times 45 divided by 145 would give us 0.155 molar solution. And this is calcium hydroxide. You can always add your chemical to it, your answer as well. So what is that saying? Okay, well we have 45 milliliters of our 0.5 molar solution. We add 100 milliliters of water to it. Our new molarity should be less because we're diluting it, and it's 0.155. So that is less than 0.5. All right, so I hope you're seeing how we can use this equation. Really important to read your context of your question. Think about what molarity and volume are paired together, and read it, see if things are being added or if it's telling you a new final volume, okay? Be careful with that. All right, try it out and let us know what questions you have. Thanks.